to do simplifying rational expressions, we are going to, those were the quick reviews, go back and refresh our memories on what do we do with these? What do we do with fractions? Well, I have fractions and I'm adding fractions, which means I need to have, if I'm going to add them, a common denominator. This one has a common denominator, 3, 3, and 3. So as long as my denominator is the same, I can just rewrite that as over 3. And that would be 1 plus 2 minus 5. Well, 1 plus 2 is 3. 3 minus 5 is negative 2. And that cannot be reduced anymore, so I'm done at that point. All right? But what happens if they're not the same denominator? I know, this is good stuff. Now I don't have the same denominator, so I need to have the same denominator. And here's where we would go back and we'd say, well, I need to find the common denominator. Common denominator will be 6. All right. How do I make the 1/3 into something out of 6? I am going to multiply it by 1. Because if I do 1/3, that's really an ugly looking 3. If I do 1/3 times 1, I still have 1/3. But the 1 I'm going to write as a very different looking. It's not just going to be the number 1. It's going to look like something that is 1. Because 2 over 2 is 1. But when I do that, it allows me to multiply. 2 times 1 is 2. 2 times 3 is 6. So this becomes 2/6. Then I've got my next fraction, 2/3. I'm going to multiply that by something that's equal to 1 because 1 times 2/3 is still going to be 2/3. And this one I'm going to multiply also by 2 over 2. The reason why I choose 2 over 2 is because 2 times 3 is 6. And that's what I want to get to for a denominator. So that'll be 6th in the denominator. And then 2 times 2 in the numerator. So then that would be 4. And then the 6th is still, or the third term is still 6th. So I can just say minus 5/6. So then I'll have 2 plus 4 minus 5. 2 plus 4 is 6. 6 minus 5 is 1. That cannot be reduced. I'm done. So this was just a quick little refresher reminding us this is how we do fractions. And then, of course, we have to go beyond this. And we go to something like this, where I have 3 things on the left that I need to add. Do they have the same denominator? No, they do not. So I need to multiply them by something so that they become the same denominator. And I want my common denominator to be 6x, 6x, and 6x. Now, if you're wondering, how did he know that that's what I'm looking for? Well, this has 6x, this has 3x. Well, they all have x's, so I don't need to do anything there to change that. So I just need to change the coefficients. So this is a 6, and I need to make the 3, the lowest common denominator. Well, 3 will go into 6 2 times, so I'm going to multiply this by 2 over 2. I'm going to multiply this one by 2 over 2. And when I do that, I'll have 2 over 6x, and then 4 over 6x. Don't forget to bring down the math symbols, right? That's plus, that one's minus. And then the last term is 5. And again, what I'm doing here, just unsimplifying. Back in the day, we do this and say, oh, you get your fraction at the end. Don't forget to reduce your fractions. We're unreducing so that I can have a common denominator. Once I have all the same denominator, then I can start doing all of these fractions. 2 plus 4 minus 5, which will then be 6 minus 5, 1 over 6x. I cannot reduce that anymore, so I would be done. Look to the next one. 3x, 3x, and 6. my common denominator needs to have an x in it. Also has to have 6. So 6x, 6x, and 6x will be the three denominators. So I need to look at each of those portions and say, well, what am I going to do? I'm going to multiply this by 2 over 2. I know that because 2 times 3 will give me the 6. I'm going to multiply this second one by 2 over 2. Again, I know that because the 2 times the 3 will give me the 6 in the denominator. And then the last one is already 6, but it doesn't have an x. So I'm going to multiply it by x over x. And again, I'm multiplying each of these by 1. When I multiply by 1, I do not change its value. I just change how it looks. This one I'm multiplying by 1, but it's a special form of 1. It's 2 over 2. This one I'm multiplying it by 1. So I'll end up with 5x over 6x. Which, if I'd go reverse direction, say, can I reduce this? Yeah, the x's would reduce, and I'd be left with 5, 6. So see, that's all I'm doing is I'm taking this, I'm unreducing it so that I got to bring down our symbols. This is minus. 2 times 2 in the numerator there. This one was plus. And then 2 times 1, and that's 2. Now I have common denominators. Now I can combine my fractions. So I have 6x in the denominator. I will have 2 plus 4 minus 5x. All right, 2 plus 4 is 6. 6 minus 5x is 6 minus 5x. 6 minus 5x cannot combine. They are different. Divided by 6x. Can I reduce? Do they all have an x? No. Do they all have a number I can divide out of them? No. So that one also is then simplified. Now, of course, it'd be great if it would stay this simple, but, you know, it won't. Do they have the same denominator? Yes. So I can combine them straight away without doing anything about the denominator. That's x plus 1. And up here I'll have 2x plus 3 plus x. Sorry, I forgot to write that other one. Can that simplify? Certainly. 3x plus 3 over x plus 1. Now, we get to this place and say, oh, I'm done, but we're not quite done yet. Once we've done this, when we start getting to some of these more complicated problems, then I have to go back in my brain and say, can I factor it? In the numerator, I can. 3x plus 3 can be factored into 3 times x plus 1. In the denominator, I still have x plus 1. So again, procedurally, first, are they common denominators? Hold on. If they are, oh, what did I do? This is to subtract. It's minus x. Well, that changes everything. Now it's minus x, which means this is not 3x. I have 2x minus x. That's just x plus 3, which means that is not what we're doing next. We will get there, though. Can I reduce these x's? Everybody say no. No. When reducing, you have to remember, I can simplify things that are being added and subtracted together. I can simplify things that are being multiplied and divided together. This x is being added to 3, so I cannot divide it into x because I can't divide a thing being added or subtracted. You can't mix and match. When I'm adding and subtracting, all combine like terms. When I'm multiplying and dividing, and reducing is dividing, so when I'm dividing, it can only be something that's being multiplied. So these x's cannot reduce. This one is done. We'll do the next one. They are both over x plus 1. All have 2x plus 3. Here's where we got to be careful. Minus x and minus 2. Both of these things are being subtracted. If it helps, put parentheses on it. Minus x is minus x. Minus the 2 is minus 2. Most common mistake I'm going to see is people will write, and it will be wrong, but they'll write 2x plus 3 minus x plus 2. Because they forget that this minus is to the whole fraction. So that negative needs to distribute to each of those two things. Then combine terms. 2x minus x, right? Because I got a 2x and I've got a negative x. That adds to x. I have 3 minus 2. That would be 1. My denominator is x plus 1. Am I done? Can I reduce? No. I'm hearing a no, and I'm hearing a yes. 1. X plus 1 divided by x plus 1. Doesn't matter. Put in any number you want for x. Add 1 to it. Now do the exact same thing in the denominator. It will be the exact same number, top and bottom. So this ended up equaling 1. Do I have the same denominator? Yes, I do. So I'll have 2x plus 3 minus x minus negative 3, keeping track of those negative signs. The minus goes to the x, the minus goes to the negative 3, making it negative x and positive 3. So this will be x plus 6 over x squared plus 1. Can I factor the denominator? I'll tell you right now the answer is no. If it were going to be one of the special forms that we have that we spent the most time in is difference of squares, this one's adding, so this would be sum of squares, and I don't have a factoring method for the sum of squares. So that one is also done. Same denominator, same process. (3x squared plus 4x). As soon as I see that minus, I'm going, ooh, I'm going to really make sure I pay attention. Minus 11x. Minus a negative 4. Double negative makes it a positive. Now I'm going to see if I can simplify this any. I can. They both have x terms. 3x squared. And I have a 4x and a negative 11x. See, 4 and negative 11 is negative 7x plus 4. all over x minus 1. And now I have a quadratic. Back to quadratics from the last several lectures. I'm going to see if I can factor this. It would be very hard to just go straight to this. So, and the reason why it'd be very hard is this first number is not 1. Since that would be the hard way to go, what's the easy way to go? I'm going to do factor by grouping, or see if I can. Over here on the right-hand side, choose another color. We'll do blue. A times C is equal to 3 times 4, which is 12. The A was positive. The C was positive, so this is positive, which means I need two numbers that multiply to 12. They're either both positive or both negative. 3 and 4, negative 3 and negative 4. And what I'm looking at from these over here is, do any of them add up to negative 7, the middle term? Negative 3 and negative 4. So this is my method for breaking this middle part into two things. So 3x squared will, instead of negative 7x, it will be minus 3x and minus 4x plus 4. And what I'm going to do is I'm going to go ahead and just work that part down, and then when I'm done, I'm going to put the x minus 1 underneath. I have two groups. Factor by grouping, I'm going to factor the 3x from each of these. This one has an x, this one has an x. This one has a 3, that one has a 3. So I factor out the 3x. Leaves me with x minus 1. The next one, I'm going to factor out negative 4. Sometimes people ask, well, why don't I factor out just the 4? Because when I'm done, I want the x to be positive, and the only way to do that is factor out the negative. If I factor a negative 4 out of positive 4, I have negative 1. And as I've said in the past, all we did is I took this and I divided by 3x and 3x. I did this, I divided by negative 4. I did that, divided by negative 4. That's what factoring is. Factoring is division, and it's reverse distributive property. Taking the negative 4 out of each of those. And then, look at that. If I did it the right way for factor by grouping, and I found a pair that multiplied and added, the thing inside the parentheses will be the same. That's the goal of factor by grouping. So if I factor that out, x minus 1, it leaves me with a 3x, and it leaves me with a negative 4. So I get x minus 1 times 3x minus 4 all over x minus 1. Can I reduce? Yes. Oh, but you know what I should do right now is remind us of what we did the last time we were together in this classroom. Do I have any restrictions on the domain? Do I have any impossible numbers? Does anything make the denominator 0? X cannot be 1. If I put 1 in there, I get 0 in the denominator. Even though on this next step, watch what happens. X minus 1 divided by x minus 1 reduces, leaving me with only 3x minus 4. This entire original series of things that goes on ends up simplifying to just 3x minus 4. But I need to have this little special caveat, this little don't forget number that says the original up here had x minus 1 in it, which means I have to make sure that I never use 1 in the original equation. In the next math class, we'll learn that that's called a point of discontinuity. But that's for other times. Are my denominators the same? Wow, they're really close to the same thing. What's the one thing that's different? These are same numbers, they're just different signs. So what we're going to do with this, it's actually not too complicated in terms of, I'm going to change this sign to negative, and then I'm going to just change the order. Because what I did is I factored a negative 1 out of 5, which makes it negative 5. Factor the negative 1 out of negative x, makes it a positive x. And then the numerator stays the same as 4x plus 5. Now I have the same denominator. I'm subtracting 4x and I'm subtracting 5. X squared minus 4x minus 5. I'm going to now say x cannot be 5 because I look at my denominator and say, oh, can't have 5 in the denominator. And now I'm going to work to see, can I reduce this even more? Two numbers that multiply to negative 5 that add to negative 4. This will be x and this will be x. The only two things that add to 5, multiply to negative 5. Negative 5, so either 1 and negative 5 or negative 5 and 1. That was the same thing. 1 and negative 5 or negative 1 and positive 5. There we go. And because this is a negative, that means they're opposite signs. The middle number says the larger of the two values has to be the negative number. And if we just want to look at that and try to verify, does negative 5 and positive 1 add to negative 4? Yes. Does negative 5 and positive 1 multiply to negative 5? Yes. My denominator is x minus 5. Can I reduce? Yes. This entire thing and that entire thing can reduce, leaving me with just x plus 1. Will a lot of the problems that we do have this happen? Yes. We'll combine them together after all the work we do, then we'll factor, then we'll reduce, and we'll find out it simplifies to something much nicer and easier. But now, here's these. This one is now back to some of the problems we started with fractions. These are not just reversed order because one of them is adding, the other one's subtracting. So here's what we're going to do. We're going to multiply this first one by 1. And we're going to multiply the second one by 1. But it becomes a little bit bigger of a 1. Because my denominator will end up being x minus 1 times x plus 1. And I'll have my second fraction with x minus 1 times x plus 1. I'm now going to streamline one of my steps. 3 times x minus 1 is going to be 3 times 1 and 3 times x. So I'll have 3x minus 3. This one here will be 5 times x and 5 times 1. I missed my arrow. which is 5x plus 5. My numerator is adding, which is nice, 3x plus 5x, 8x, negative 3 plus 5 is 2. That can factor. Because again, I just divided a 2 out of each of these. I'm going to identify, before I do any reducing if I can, x cannot be 1. X cannot be negative 1. Because that would make my denominator 0. And then I look to see, do I have an exact replica of anything in the denominator in the numerator? Does x minus 1 exist in the numerator? No. Does x plus 1 exist in the numerator? No. And there are no coefficients. This cannot be reduced anymore. So now I have a whole mess in the denominator. It's usually going to be best, in my best interest, if I can factor these things first. So I'm going to take my numerator, and 9 is just 9. And then I take my denominator and look, can 7x squared and 28x both be divided by anything that's the same? 7x will go into both of them. How do I know that? Well, 7 and 28 are both divisible by 7. X squared and x are both divisible by x. This will leave me with x plus 4. Right-hand side, I'm going to have 11 in the numerator. And now I'm going to do this because I see the x squared. And because this is just a 1, the x squared is a 1, that's why I don't have to do factor by grouping. I could, but I don't have to. Instead, I can just say what two numbers multiply to positive 16 that add to positive 8. 4 times 4, positive and positive. 4 times 4 is 16. 4 plus 4 is 8. So it's going to be x plus 4 and x plus 4. So now I'm going to look at my two denominators and say, what do I need to do to make them identical? The one on the right here has x plus 4 and x plus 4. Well, that means the one on the left needs to have, come on now, an x plus 4 and another x plus 4. Which means the one on the left, I'm going to multiply by at least x plus 4 over x plus 4. If I do that, I'll have 2x plus 4s. I have 2x plus 4s. That's good. What else do I need? Well, the one on the left has a 7x. The one on the right does not. So the one on the right is going to be multiplied by 7x over 7. No, that's just terrible writing. 7x. And now I look at my denominators and look to see, will they be the exact same thing? This is x plus 4, and 7x. This one's x plus 4, and 7x, all being multiplied. So at that point, yes, I have common denominator of 7x times x plus 4 times x plus 4. In the numerator, I'll have 9 times 4 and 9 times x, which will be 9x plus 36. This is minus In the numerator, I'll have 11 times 7x, which is 77x. In the denominator, I'll have 7x times x plus 4 times x plus 4. My final answer, aside from if I can reduce anything, 7x, x plus 4, x plus 4. Numerator, 9x minus 77x. Negative 68x. That's where you should always be checking my subtraction. If I'm going to make mistakes, it's almost always with subtraction. Plus 36. Now if, let's do this. X cannot be, what makes them in the denominator 0? Negative 4. And this is the one people a lot of times miss. I have an x right there. 7 times what number is 0? Yeah, 0. So x cannot be negative 4, x cannot be 0. But then my numerator. If both of these numbers are divisible by 7, I'd factor it out and could reduce it, but I know 36 is not divisible by 7. So I'm done at that point. Could I factor that numerator a little bit? I could, because they're both divisible by some even numbers. But you wouldn't have to. If you know that, it can't reduce with a 7. It's always a good idea to look at that and say, oh, what can I factor out of 36 and out of 68? Because if I divide 68 by 2, actually I could divide both of them by 4. I don't think I can divide them both by 6. And not 8 either. So the highest number that goes into both is 4. So you could rewrite that as 4 times negative 17 plus 17x plus 8. But the 4 will not reduce with the 7.
How'd you get 77?
All right, this is my last slide for today. Going to start with, can I factor? Oh, this one's going to be factor by grouping. 2 times negative 3 is negative 6. That's the A times the C. So negative 6, I need two numbers that multiply to negative 6. So negative 6 and 1. Negative 2 and 3. 2 and negative 3. I need a pair that adds to negative 1. This pair here. So I'll have 2x squared plus 2x minus 3x. Again, that's the grouping. What's going to happen here? Those two numbers that we found that multiplied to the negative 6, which was A times C, that add to the middle number. And then I still have this minus 3. Going to group them. 2x comes out of that, and you have x plus 1. Negative 3 out of both of those leaves me with x plus 1. And if, again, because I was doing it right, it'll be x plus 1 times 2x minus 3. So now I have on the left-hand side x squared, change my color here, x squared minus 2 over x plus 1, 2x minus 3, plus x minus 2 over 3 minus 2x. Couple ways to go. with practice, you'll recognize that this 3 minus 2x is this, but with the wrong sign. So we did a problem like this before. So I'll just show the intermediate step, x squared minus 2 over x plus 1 times 2x minus 3. This was positive. I'm going to make it negative. And when I do that, I'm going to rearrange those bottom two with opposite signs. The 3 becomes the negative 2x becomes the positive. In the top, I'll still have x minus 2. And now, I nearly have the same denominator. I'll multiply this half times x plus 1 over x plus 1. And when I do, I will have x squared minus 2 over x plus 1 times 2x minus 3 minus x plus 1 times x minus 2 over x plus 1 times 2x minus 3. Same denominators. I can start to combine. When I do, and this is where I'm going to leave you today and see if you can finish this one up. What you're going to do first to finish this one up is FOIL this. Then you'll go this minus all three of the things that you get when you FOIL. When you combine them together, then you're going to look to see, can you then refactor it? In hopes of maybe eliminating one of these things in the denominator. But before you get to that point, don't forget, x cannot be negative 1. X cannot be 3/2. If you're wondering how I did that, take 2x minus 3, set that equal to 0. Subtract 3 from both sides, or add 3 to both sides, so it'd be 2x equals 3. Divide by 2, x equals 3/2. This is a bit more of a spicy problem, a lot more complicated than what you're going to see on the exam, but it adds everything into all one problem. It's common denominators, it's factoring again, it's foiling, it's then reducing, and it's all that good stuff. All right, then.